Answer key for 3.1 to 3.5 review questions. So we got some multiple choice like every AP exam does, and then some open response. F of x equals x plus 1, absolute value of x plus 1, something like this. Is it continuous? Yes. Is it differentiable? No. It has a corner? Yes. Done. Reminder, there will only be 4 choices on the actual AP test, but I had 5 when I wrote these up, and I ain't going back to change one stinking answer. If the normal of the graph of f at the point passes the point -1, 1, if the normal graph of f at the point 1, 2 reaches the point -1, 1, normal, which is the following is the value of f prime of 1. So, in other words, there's some weird curve here, who knows? Tangent line is the derivative of that curve at that point. So slope of this one is m of the perpendicular, really should say normal, is 2 minus 1 over 1 minus -1 equals 1/2, which makes sense if you look at it. So the slope of this is -2. Find dy dx if y equals 4x minus 3 over 2x plus 1. Low, d high minus high, d low. Pretty sure these are wrong. This is a very good technique, by the way. Can't eliminate that one quite yet because you never know what's going to happen. 8x plus 4 minus 8x plus 6, 10. Cool. If the line tangent to the graph of the function f at the point 1, 6 passes through the point, then f prime of 1 passes through the point tangent line, then f prime of 1 is just the slope of this line. M equals f prime of 1 equals 6 minus -4 over 1 minus -1, 10 over 2, 5. Which is the following, gives the second derivative. Okay, y prime equals negative sine of x plus secant of x, secant of x, secant of x, secant x squared, but secant squared x. But it's easier if I write it this way. This is a very good AP problem. Just get you thinking a little bit. Negative cosine of x, kill, plus, leave it, leave it. In other words, 2 secant squared x tangent x. 2, so there it is. And if y equals all this nonsense, we've already done this fun times. Could be that, but I highly doubt it. Equals, why is there a period there? Dy dx low, d high minus high, d low over now. I am personally getting impatient with these problems. This is when I make mistakes, but I'm going to try it anyway. 6x minus 6x. Why do they do that? 9 minus 4. 5. Yeah, very easy to make a mistake on the negatives. Got to double check, but good. for your response. Points with F has horizontal tangents. While we're up here, F prime of X equals 4x to the third minus 8x. Well, that's where 4x to the third minus 8x equals 0. 4x, x squared minus 2 equals 0. They usually have a little bit neater problem here. Find all the points. Now, it's not clear, so x equals 0, comma, square root of 2, negative square root of 2, square root of 2. Really should be plugging those back in, but I'm going to be a little lazy right now. No, I'm not. 0, comma, 0. Same answer out of either one, so negative root 2, root 2. Root 2 times root 2 is 2, times 2 is 4. 4 minus 4 times 2, negative 4. Kind of a hassle. But equation of tangent line at x equals 1. I need that point, so let's go get that point. F of 1 equals 1 minus 4 equals negative 3. So that point is 1 comma negative 3. Kind of nice to know that. Tangent line at x equals 1. 1, plug it into the derivative. 4 plus 8 is 12. Nah, that's not right. 4 minus 8. That was painful. Why is that saying positive? Boy. Especially when it says negative here. Weird. All right, y minus negative 3, y plus 3 equals negative 4, x minus 1 minus 3. Nice. Find equation of the normal line. Y equals 1/4 x minus 1 minus 3. Nice. Part moves along the line, so its position at a given time, and t squared plus 2 plus 2, where s is the measure of meters, seconds, initial position of the particle. In other words, what's s naught? Well, s of 0, it's not s naught. S of 0 equals negative 0 squared plus 0 plus 2 equals 2 meters. Find the velocity of the particle at any time t equals s prime of t equals negative 2t plus 1 meters per second. I was going to forget my units there, but fortunately my answer key bailed me out. When is the particle moving to the right? Well, let's set the velocity to 0 and get t equals 1/2 seconds. And this is something we're going to do later, but I'm going to start doing it now. We graph that velocity and we say, this is when it's 0. So if I plug in something less than that, like 0, I get 1, so it's positive. And if I plug in something like 1, I get negative 2 plus 1 is negative. Negative. So that's moving to the right, that's moving to the left. That's moving up, that's moving down. Stupid stuff. I'm getting ahead of ourselves a little bit, but such is life. Line where s is measured at any time t is greater than 0. So moving right when t is greater than 1/2 seconds. Something tells me I made a mistake. Yep. That's weird. That's moving to the right. Why would I say it that way? So weird. When 0 less than or equal to t less than 1/2. And acceleration of the particle, man, if you just give me, when it's going left, that makes my life nice and easy. Such minor a of t equals s double prime of t equals negative 2 meters per second squared. Find speed of the particle at the moment when S of t equals 0. When 0 equals negative t squared plus t plus 2, we get t squared minus t minus 2 equals 0. T minus 2, t plus 1 equals 0. T equals negative 1 comma 2. All right, so that's 1 equals 0. So then I have to throw out negative 1 because we're only working in the greater than world. V of 2 equals negative 2 times 2 plus 1 equals negative 3 meters per second, and speed is the absolute value. Three meters per second. Sorry, just ran off page a little bit. A little bit. Particle moves, position given, find velocity. They give us x of t this time, just to keep us on our toes. There it is. Acceleration. No units. We've got to see which particle's at rest. We don't use the negative here because of this. I don't write in seconds. Well, it's always seconds. I don't write in seconds. Find the speed of the particle when its acceleration is 0. A of t equals 6. T equals 0. T equals 0. We are allowed to use that. Speed of the particle. Speed of the particle. Absolute value v of t equals absolute value of 3 times 0 minus 12 equals 12. No meters per second, no feet per second. They just give me that. It is particle moving toward the origin, away on the from the origin when t equals 3. At t equals 3, v of t equals 3 times 3 squared minus 12. 27 minus 12 equals 15. Therefore, particle is moving away from the origin. Well, it's moving to the right at the time, but I don't know if it's at the origin or not. Let's check. What's S of 3 equals 9 times 3, 27 minus 36. 9, negative 9 plus 5. Wow, can't believe I would have missed that. Negative 4. So that and that means it's left and moving to the right. Whew, that would have been sad to get that wrong. All right, next. Let f of x equal this ugly cosine over cosine thing. Get your graph. F in the window. You should go ahead and do this. You should do this on your calculator, I was going to say. Okay, in case you're wondering, horizontal increments are pi over 4. F prime of x equals low cosine of x minus 2 d high, negative sine of x minus high, cosine of x d low minus sine of x. So these are going to cancel, but they're not. Close. Over cosine of x minus 2 squared. Negative sine times cosine is negative sine cosine. Negative, negative, positive sine cosine. They're all going to cancel. I'm left with 2 sine of x. Find all values in the domain of f for which f prime of x equals 0. We only need the top, although we do have to check that we don't screw up on the bottom. It's just impossible to screw up on the bottom because cosine can never get greater than 1 or less than negative 1. So the bottom will never be 0. So 2 sine of x when the sine equals 0. It's a 0. And what they give me a domain? Well, they said to graph it, and oh, there it is. I was going to say in that window, but no. X equals 0 plus or minus pi included plus or minus 2 pi. Range and parts A and C, find the range of f. A and C to find the range. Oh, so that's peaks and valleys. Right. So sketch a graph, right? And at the peaks and valleys, that's our max and mins. So just plug in 0 and plug in pi, and that should give you everything you need. So highest point. X equals pi. F of pi equals cosine of pi over cosine of pi minus 2. Cosine of pi is negative 1. Negative 1 over negative 3 equals 1/3. That's there, which is not even close to what I have drawn, so sorry about that. Let's cheat. Lowest point, x equals 0. F of 0 is cosine of 0 is 1. 1 minus 2 is negative 1. Equals negative 1. There it is, negative 1. RTFQ range, negative 1 to 1/3. Inclusive. Let's see if I want to do any more of this. I've lost part of my answer key, and I think I did that on purpose. No, I'm definitely doing those. You can't get enough practice at this point. You just can't. What happened to my last page, my answer key? Oh, the humanity. I'll have to do it the long way and then check my work. All right, function f is differentiable for all numbers. Function g is defined by this. We don't know f of x, but we can do it all with this. This is a very typical AP kind of problem. All right, x equals 4. That's at 4 comma. We want to take the graph of f. So we want f of 4 is 3. So there's our point. And then f prime of 4 is 5. Tangent line y minus 3 equals 5x minus 4 plus 3. Notice how carefully I have to read the question. I can't just buzz through it and say, yeah, I know what they're talking about. Is f continuous at x equals 3? Justify your answer. Function f is differentiable. Yes. If differentiable, then I never know if that's an E or an A. Also continuous. Is there 0 of f in the interval 2 to 4? Well, 2 is in negative territory, 4 is 3, and it's continuous. Yes. Goes from -1 to 3 by the intermediate value theorem, must hit x-axis. Sorry for that. I really should zoom out, but I hate doing that. So let's find g prime of 2. If you recall, g prime is f of x, so over f of x minus 3. G prime of 2 equals low f of 2 minus 3 d high f prime of 2 minus high f of 2 d low f prime of 2 over f of 2 minus 3 squared. Low d high minus high d low. That should do it. Equals. Sorry, I was looking at the next question. I was getting confused. F of 2, -1 minus 3. F prime of 2, 3 minus f of 2, -1. F prime of 2, 3. F of 2, -1 minus 3, -4 squared, 16. Equals -4 times 3, -12, plus 3, -9, or 16. No units, nothing like that. Explain why g is not differentiable at x equals 4. Denominator of g prime of x is f of x minus 3 squared when x equals 4, denominator equals 0, no derivative. Derivative is undefined. Now I'm going to go check my answer key and see if I screwed up. And shockingly, I did everything right. It'll never happen again, so let's enjoy the moment. Good luck and happy mathing.